Prove that sin A divided by 1 plus cos A plus 1 plus cos A divided by sin A is equal to 2 cosecant A. As soon as we see that arithmetic, the positive in the denominator, we need to change this. This can be changed into a single trigonometric function by multiplying both numerator and denominator with this term by changing the sign of this. Sin A divided by 1 plus cos A, multiply and divide this by changing the sign here. This is sin A into 1 minus cos A divided by 1 plus cos A into 1 minus cos A. So we are multiplying and dividing, multiplying both numerator and denominator with 1 minus cos A, a denominator 1 minus cos A, and we are keeping the second term as it is, plus 1 plus cos A divided by sin A. See, when you multiply these two, we are keeping like that. When you multiply the denominator, this is in the form of A plus B into A minus B, that is A square minus B square. A square is 1 square, that is 1. B square is minus, B square is cos square A, then rest we are keeping like that only. Here this 1 minus cos square A is sin square A, because 1 is equal to cos square A plus sin square A. Therefore 1 minus cos square A is equal to sin square A. We have sin A in the numerator, sin square A in the denominator. Sin A will get cancelled with one of the sign here, so we are left out with 1 divided by sin A. We are taking, because sin A is here, one sin A is left out here, one sin A is left out here. We are taking sin A as common, 1 by sin A is common, 1 minus cos A is left out here, and 1 plus cos A is left out here. And minus cos A plus cos A will get cancelled. The 2 divided by sin A. 1 divided by sin A is cosecant A, therefore 2 cosecant A is equal to RHS. So in this problem, this thing is this. So multiplying both numerator and denominator is with changing the sign of the denominator, 1 minus cos A, and here writing 1 minus cos square A as sin square A, then taking common as this, rest is prove that cosecant A minus sin A, secant A minus cos A multiplied with secant square is equal to tan A. We need to prove that right hand side is equal to tan A. Tan A is sin A divided by cos A. So whatever there in the other than sin and cos, change it to sin and cos. Cosecant A is 1 by sin A, secant A is 1 by cos A, secant square is 1 by cos square A. They keep sin and cos as it is. So we are converting cosecant into 1 by sin A, secant into 1 by cos A, secant square to 1 by cos square A. So we have sin here, take the LCM sin A. Once you take sin A is common, 1 minus sin into sin square it has come. Here take cos A as LCM, then 1 minus cos square A divided by cos A, then keep this 1 by cos square as it is. From here to here it has become sin square A, from here to here it has come cos square A. Now 1 minus sin square A is equal to cos square A, because 1 is equal to sin square plus cos square A. When sin square A comes this side, it will become cos square A. 1 minus cos square A is equal to sin square A, then keeping all the things as it is. So now cos square A divided by sin A, sin square A divided by cos A, 1 divided by cos square A. This cos square A get cancelled with cos square A, 1 sin A and 1 sin will get cancelled here. We are left out with sin A divided by cos A, that is equal to tan A, which we have proved as RHS. Prove that cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A is equal to cos A plus sin A. We want an RHS cos A plus sin A. So keeping all cos A and sin A, rest change it to cos A sin A form. We have here in the denominator tan A, change that into sin A divided by cos A. We have done it here. And cot A is there here, change that into cos A divided by sin A. So from this step to this step we have changed only the tan A to sin A divided by cos A, cot A to cos A divided by sin A. So here once again what we have to do is take the LCM, that is cos A in this, sin A in this. Once you take the cos A as, then cos A minus sin A it comes, this one will become cos A minus sin A, this will become sin A cos A divided by sin A, this will become cos A minus sin A divided by cos A. When this goes up, cos A into cos A, that will become cos square. Here sin A minus cos A divided by sin A, it will become, so when this goes with sin square, so we have got cos A minus sin A, cos square A divided by cos A minus sin A, plus sin square A divided by sin A minus cos A. So now we want both the denominators same, then because of that we are taking minus as common here. Once you take minus, this comes this side and this goes this side. Here cos square divided by cos A minus sin A, we are keeping this as it is. We are changing the denominator cos A minus sin A, because that we have changed the sign, we have taken the minus as common here. So from here to here we have only changed the denominator, then both the denominators are same, we are taking as LCM cos A minus sin A. So numerator cos square A minus sin square A. So cos square A minus sin square A is nothing but it is like A square minus B square. A square minus B square is A plus B minus A minus B. Here cos A plus sin A into cos A minus sin A divided by cos A minus sin A. So we have cos A minus sin A in the numerator and cos A minus sin A in the denominator. So with these two will get cancelled. We are left out with cos A plus sin A, cos A plus sin A, which is equal to RHS. Through that, secant A divided by secant minus 1 plus secant A divided by secant plus 1 is equal to 2 cosecant square A. Cosecant means 1 divided by sin A. Let us see how can we convert this secant to sine. Before going to that, let us see whether we can eliminate secant. So we want 1 divided by sine square A, 2 divided by sine square A. So we need to eliminate whatever there in the numerator. So for that, let us eliminate first secant. For that, let us write secant as 1 divided by cos A, secant as 1 divided by cos A. Rest we are keeping like that. Secant A is equal to 1 divided by cos A into 1 divided by secant A minus 1 plus 1, because we want 2 in the numerator. We don't want anything in the numerator. That's why we are eliminating secant A. So you get in this, that will become cos A into secant A minus into cos A, plus get in this 1 divided by cos A into secant A plus cos A. So we know that secant A is 1 by cos. This cos and that cos will get cancelled. Here also cos into 1 by cos cancelled. This will become 1 minus cos A. Here 1 plus cos A. This has become cos A into secant has become 1. Cos A into secant has become 1. So now we have 1 divided by 1 minus cos A plus 1 divided by 1 plus cos A. So there is 1 minus cos A and 1 plus cos A. Let us take the LCM of these two. So LCM of these two is 1 minus cos A into 1 plus cos A. So once we take the LCM of these two, this goes here 1 plus cos A, this goes here 1 minus cos A. So in the denominator we got 1 minus cos A into 1 plus cos A, which is not A minus B into A plus B, that is A square minus B square, 1 square minus cos square A. This cos A plus cos A and minus cos A got cancelled. 1 plus 1 is 2, 2 divided by 1 minus cos square A. We know that sin square A plus cos square A is equal to 1, therefore sin square A is equal to 1 minus cos square A. Therefore 1 minus cos square A is equal to sin square A, 2 divided by sin square A. 1 by sin square A is 2 cosecant square A is equal to RHS. So as soon as you see this, so we want 2 in the numerator and sin square in the denominator to get the RHS. So we need to eliminate these secant. Secant can be eliminated in the numerator by writing them as 1 by cos A and 1 by cos A and getting in. Once we get it, we got this 1 minus cos A and 1 plus cos A. As soon as you see this, so if you take the LCM of these two, you know that it can be written as 1 minus cos square A. We know that 1 minus cos square A is sine square a. So we got the answer which is required. So you should not get confused. As soon as you see nothing is there in sine here, you used to start one step after the other. Do not get panic. What we want in the numerator, we want 1 in the numerator, 1 here. So just eliminate secant a and follow the steps as it goes on. Through that, 1 divided by sin a plus cos a plus 1 divided by sin a minus cos a is equal to 2 sin a divided by 1 minus 2 cos square a. So we need in the denominator cos square a, in the numerator sin a. So this is very important. We have to, whatever we get, it should be in the form of cos square a. So come to the LHS. So we cannot do anything with these two because we need only sin and cos. Then we have to keep all sin and cos as it is. So what can be done here? There is a plus sign here, 1 divided by this, 1 divided by this. We have, only thing is we can take the LCM of these two. We have taken the LCM of these two, that is sin a plus cos a into sin a minus cos a. Once you take the LCM, then you get in the numerator sin a minus cos a plus sin a plus cos a. We have minus cos a here and plus cos a here. In the denominator we have a plus b into a minus b form. We have sin a 1 here and sin a 1 plus 1 is 2 sin a, which is the numerator of RHS. Don't do anything with this, keep as it is. So we know that the denominator has become sin square a minus cos square a. So we have the chances of converting this to cos square and this to sin square. So what we want in the RHS is cos square. Better convert this sin square into cos square. So 2 sin a divided by, we know that sin square a plus cos square is equal to 1. Therefore sin square a will become 1 minus cos square a minus cos square a. 1 minus 1 here and 1 here. 2 sin a divided by 1 minus cos square a is equal to RHS. This is what it was required. Prove that 1 minus sin a divided by 1 plus sin a is equal to secant a minus tan a whole square. Here, as soon as you see in the denominator 1 plus sin a, multiply both numerator and denominator by changing the sign of the denominator here. 1 minus sin a divided by 1 plus sin a, multiply both numerator and denominator with this changing sign of this denominator, that is 1 minus sin a divided by 1 minus sin a. So we know that 1 minus sin a into 1 minus a is 1 minus sin a whole square. A plus b into a minus b, that is a square minus b square, that is 1 square minus sin square a. We know that 1 minus sin square a is cos square a. So expand this, a minus b whole square, a square minus b square plus a square plus b square minus 2ab. A square is 1 square plus sin square minus 2 into sin a divided by 1 minus sin square a is cos square. So we have these things. So divide, use this cos square for all the things. So 1 divided by cos square, sin square divided by cos square minus 2 sin by cos square. 1 divided by cos square a, sin square a by cos square. This 2 times sin by cos. This cos we use it in 2 places, 2 here. Sin by cos, 1 by cos. This is secant square a, tan square a. 2 times minus 2 times sin by cos is tan, 1 by cos is secant. This is in the form of a square plus b square minus 2ab. So here we wanted secant and the first in the a place minus b tan. So write secant a minus tan a whole square, which is equal to RHS. So first you have to, what you have to do is multiply both numerator and the denominator with changing the sign of this denominator. The rest is simple calculations. Prove that 1 plus cos a divided by 1 minus cos a is equal to cosecant plus cot a whole square. This is similar to the previous problem. See here there is a minus sign in the denominator. So change the sign of the denominator and multiply both numerator and denominator with this denominator. 1 plus cos a divided by 1 minus cos a multiplied with 1 plus cos a with the numerator, 1 plus cos a with the denominator. So this into this will become whole square, 1 plus cos a whole square. This into this, a minus b into a plus b, that is a square minus b square, 1 minus cos square a. Expand this, a plus b whole square, a square plus b square plus 2ab, 1 plus cos square a plus 2 cos a divided by 1 minus cos square a is sin square a. And use this sin square for all the numerator, this thing, divide 1 divided by sin square a plus cos square a divided by sin square a 2 times cos a divided by sin square a. So 2 times 1 by sin a, we are splitting the sin square a into two parts this here. Sin into sin square a, 1 divided by sin a, because we want cosecant a and cot a. So 1 by sin square is cosecant square a, sin square a by cos square a by sin square is cot square a, 2 times 1 cosecant a cot a. So this is in the form of a square plus b square plus 2ab. Then it can be written as a plus b whole square. In place of a we have cosecant a, in place of b we have cot a. Cosecant a plus cot a whole square, which is equal to RHS. Prove that 1 divided by cosecant a minus cot a is equal to cosecant a plus cot a. As soon as you see the denominator, change the sign of the denominator and multiply both numerator and denominator with the thing cosecant a plus cot a divided by cosecant a plus cot a. So this will become a minus b into a plus b, that will become cos a plus cot b divided by cosecant square a minus cot square a. We know that 1 plus cot square a is equal to cosecant square a. Therefore 1 is equal to cosecant square a minus cot square a. So we can write in place of cosecant square a minus cot square a is equal to 1. Then what we get left out with cosecant a plus cot a is equal to RHS. Prove that secant a minus tan a divided by secant a plus tan a is equal to 1 plus 2 tan square a minus 2 secant a tan a. As soon as you see something of this form in the denominator, multiply and both numerator and denominator by changing the sign of this. So that is what we are doing, changing the sign of the denominator and multiplying both numerator and denominator with this. This will become secant a minus tan a whole square. This is in the form of a plus b into a minus b, that become a square minus b square. A square is secant square a minus tan square a. So we know that 1 plus tan square a is equal to secant square a. Therefore 1 is equal to secant square a minus tan square a. In place of secant square a minus tan square a, we can write 1. So we are left out with the whole square secant a minus tan a whole square. Then expand this a minus b whole square, a square plus b square minus 2ab, secant square a tan square plus tan square a minus 2 into secant a tan a. So in place of secant square a we can write, so because we need this, so in place of tan square we have tan square, in place of secant square a we can write 1 plus tan square a. Secant square a is equal to 1 plus tan square a plus tan square a minus 2 secant a tan a, that is equal to 1 plus tan square a plus tan square a is 2 tan square a minus 2 secant a tan a. Here we need to use this because we wanted 2 tan square a, that's why we are replacing secant square a with 1 plus tan square a. So we got the final answer here. Prove that sin a divided by 1 plus cos a is equal to cosecant a minus cot a. Here also denominator we have a 1 plus cos a. As soon as you see this, multiply and divide, multiply both numerator and denominator with this by changing the sign of the denominator. So we are multiplying in both numerator and denominator with this 1 minus cos a divided by 1 minus cos a. So this will become a square minus b square. Then we are multiplying sin a into 1 minus cos a, 1 minus cos square a. We know that sin square a plus cos square a is equal to 1. Therefore sin square a is equal to 1 minus cos square a. We are replacing with 1 minus cos square a with the sin square a. So with this one sign and one sign here get cancelled, we are left out with 1 minus cos a divided by sin a. So use this sin a for it belongs to both 1 and minus cos a. So divide 1 by sin a and cos a by sin a, 1 divided by sin a minus cos a divided by sin a. So 1 by sin a is cosecant a and cos a by sin a is equal to cot a, which is equal to RHS. Prove that tan square a divided by 1 secant minus 1 whole square is equal to 1 plus cos a and 1 minus cos a. We need the right hand side RHS as cos a. So let us see what can be done with this. So tan square a we have sin secant. Let us convert tan into secant. This can also be converted into sin by cos or cos by, but it is very easy to eliminate secant a in the denominator if we convert tan square a into the secant square a. We know that 1 plus tan square a is equal to secant square a. Therefore tan square a is equal to, this comes this side, secant square a, secant square theta minus 1. So tan square theta can be written as secant square theta minus 1 divided by secant theta minus 1 whole square. So we can see that this is in the form of a square minus b square. We can call this 1 as 1 square, then a square minus b square is equal to a plus b into a minus b. We are writing here. secant theta plus 1 into secant theta minus 1 divided by secant theta minus 1 whole square. 1 secant theta is here, secant theta minus 1 here, secant theta minus 1 whole square. We'll remove these two. We are left out with secant theta plus 1 divided by secant theta minus 1. So we want in the right hand side cos, so convert the secant theta into cos. So we have to keep this in mind always, what you want on the right hand side. We have come here, so 1 divided by cos A, here 1 divided by cos A, we have replaced 1 secant theta by this secant theta by 1 by cos theta. So take the LCM of this. LCM, once you take the LCM, 1 plus cos theta divided by 1 plus cos theta divided by cos theta. LCM in the denominator also, 1 divided by cos theta minus 1. So 1 minus cos theta divided by cos theta. This cos theta and this cos theta will get cancelled. We are left out with 1 plus cos theta divided by 1 minus cos theta, which is equal to RHS. Prove that tan A plus cot A is equal to secant A into cosecant A. So we want 1 by cos A to get secant A, 1 by sin A to get cosecant on right hand side. So convert whatever there on the left hand side into sin and cos form. Tan A is equal to sin A by cos A, cot A is equal to cos A by sin A. So take the LCM of these two, that has become cos A sin A, and this into this sin square A, this into this will cos square A. We know that sin square A plus cos square A is 1, 1 divided by cos A sin A. So 1 divided by cos A is secant A, 1 divided by sin A is cosecant A is equal to RHS. Prove that cosecant square A minus 1 into tan square A is equal to 1. So convert all this cosecant and tan into sin and cos. So first you get in the cosecant square A into tan square A minus tan square A. Cosecant square A can be written as 1 by sin square A into sin square A divided by cos square A, that is tan square A is equal to sin square A divided by cos square A, minus tan square A can be written as sin square A divided by cos square A. So this one sin square A and this sin square A got cancelled. We are left out with 1 by cos square A, 1 by cos square A here, sin square A by cos square A. There is a cos square A here and cos square A. We are taking that as common, 1 divided by cos square A. In this, once we take out 1 divided by cos square A, left out is 1, 1. When you take out this, left out is 1 minus, this is sin square A. We know that 1 minus sin square A is cos square A, 1 divided by cos square A into this is cos square A, because 1 is equal to sin square A plus cos square A. Then for 1 minus sin square A is equal to cos square A. This cos square will get cancelled with this cos square. We are left out with 1, that is equal to RHS. Prove that square root of 1 minus cos A divided by 1 plus cos A is equal to sin A divided by 1 plus cos A. See here, an LHS, take the root for both numerator and denominator. We are taking out, we are splitting the square root for numerator and separately we are taking root separately. So don't get immediately change this sign and do it, because we want plus sign on the right hand side. So usually in this type of problems we used to take the changing the sign of the denominator and multiplying both numerator and denominator. Here in this case we need to take plus, because we have on right hand side plus, so we are taking this plus, multiplying with numerator and denominator with taking square root of 1 plus cos A. This is important, because we want the plus on the denominator and the RHS. So multiply this. So we got it. This into this, under root sign, 1 minus cos A into 1 plus cos A, that will become A minus B into A plus B. Inside the square root sign, 1 square minus cos square A, 1 minus cos square A. This is also, so when you put inside this square root sign 1 plus cos whole square, it will become, so once we remove this root, it will become 1 plus cos A. Under the root sign we have 1 minus cos square A in the numerator, that can be written as sin square A, because 1 is equal to sin square A plus cos square A. So this 1 minus cos square A has become sin square A. This, to remove this sin square, we can eliminate the square. Sin A divided by 1 plus cos A, that is equal to RHS. So as soon as you see, don't come into the conclusion that you have to change the sign and multiply both numerator and denominator with this. See the right hand side what is there. According to that you have to do this. So then you will get this. Prove that square root of 1 plus sin A divided by 1 minus sin A is equal to cos A divided by 1 minus A. This is also similar to the previous problem. So put the root for both numerator and denominator. We're changing the roots for this thing, keeping both numerator separately. So here also we need minus sign in the denominator and the RHS. So multiply and divide, multiply both numerator and denominator with 1 minus sin a with the same sign as there in the denominator, because we want the denominator this thing. So square root of 1 minus sin a. This into this, when it goes inside, it will be 1 plus a plus b into a minus b. This will become a square minus b square, 1 square minus sin a square. So this into this, we can eliminate root sign, because this will become 1 minus sin whole square. So we are eliminating the square root, taking 1 minus sin a. We know that 1 minus sin square a is cos square a, square root of cos square a. That when I can remove this cos square a by writing cos a divided by 1 minus sin a, that is equal to RHS. So here in this problem, important thing is here what you want on the right hand side, what is there on the LHS. According to that, you have to multiply both numerator and denominator. Prove that tan a plus secant a minus 1 divided by tan a minus secant a plus 1 is equal to 1 plus sin a divided by cos a. So both numerator and denominator look same except for the change in the signs here. So we cannot do anything with these. So we can always see that something can be done on the 1. So keep the denominator without changing anything, like that only. So change this 1 to, we know that 1 plus tan square a is equal to secant square a. So therefore 1 can be written as secant square a minus tan square. Therefore 1 is equal to secant square minus tan square a. Replace this 1 with this secant square minus tan square a. Tan a plus secant a minus secant square a minus tan square a. It's in the bracket. Keep the denominator as it is. So we have the secant square a minus tan square a. So change the places of this secant a plus tan a. We know that a square, it is in the form of a square minus b square. This can be written as a plus b into a minus b. So we have common here in these two, secant a plus tan a here, secant a plus tan a here. Take out that as common, secant a plus tan a. So we have left out with, we have taken this as common, 1 is left out. We have taken this as common, so we are left out with, so bring in this minus inside, we are left out only this minus secant a, minus into minus, this has become tan a. So because this 1 minus secant a, or tan a minus secant a plus and tan a minus secant a plus, so these two are same in the numerator and the denominator. These two will get cancelled. We are left out with only secant a plus tan a, secant a plus tan a. Because we want sin and cos in the right hand side, change this to sin and cos, 1 by cos a plus 1 sin a divided by cos a, which is equal to tan a. Take cos a as common, LCM. So we have taken LCM as cos a, then we are left out with 1 plus sin a. 1 plus sin a divided by cos a is RHS. In this problem, as soon as you see we can do anything with this, you just try to change 1 in 1 using this formula. So replace with this. Once you got this, you write this in a square minus b square into a plus b is equal to a plus b into a minus b. You replace the places, change the places so that we can get the common of these two. Secant a plus tan a, we have taken secant a common, secant a plus tan a is common, then bring in this sign inside this. So once you rearrange these two, so this will be, this part of numerator is equal to this part of denominator. So we are left out with secant a plus tan a. Convert the secant a tan a into cos and sin. Once we converted, take the LCM of cos a, we left out with then 1 plus sin a divided by cos a, which is equal to RHS. Prove that 1 divided by cosecant a minus cot a minus 1 divided by sin a is equal to 1 by sin a minus 1 divided by cosecant a plus cot a. So LHS and RHS looks similar. Only thing is this sign has comes this side, the sign of this, the negative sign has changed to positive sign, and this when comes this side, the inside this thing is changed. Nothing much difference is there between right hand side and left hand side. Let us see how it can be done. Let us take the left hand side first. So we wanted 1 plus sin a, you keep as it is. So don't do anything with this. So we'll see what can be done in the denominator of this part. So cosecant A can be written as 1 by sin A, cot A can be written as cos A divided by sin A, rest we are keeping as it is. So once you come here to this, take the LCM as sin A. Once you take the LCM as sin A, we are left out with 1 minus cos A divided by sin A. When sin A goes up, that will become sin A divided by 1 minus cos A. In this part, we are taking sin A as LCM, then 1 minus cos A divided by sin A, it becomes sin A goes up, sin A divided by 1 minus cos A. The whole thing has become sin A divided by 1 minus cos A. Once we know that we have anything like this in this form 1 plus cos A, so 1 minus cos A, you multiply both numerator and denominator with the same thing. That is what we are doing it here. 1 plus cos A divided by 1 plus cos A. We are keeping this same as it is till the end. So this, once you multiply with this sin A into 1 plus cos A, this will become A minus B into A plus B form, A square minus B square, this 1 square minus cos square A. We know that 1 minus cos square A is sin square A. So sin A into 1 plus cos A divided by sin square A. One sin will get cancelled with one sin here. We are left out with 1 plus cos A and sin A. 1 by sin A. So we use this sin A belongs to both 1 and cos. We are doing it here, 1 divided by sin A and cos A divided by sin A. See, 1 divided is sin A. This is what we wanted in the right hand side. So here afterwards we are not going to change this because we already got one part of the right hand side. Keep as it is. Then cos A divided by sin A minus 1 divided by sin A. So once you keep this, don't change anything. So only look into this part now. So this continues till the end. So you see this. In this we have sin A as common. You take out the common 1 by sin A. Then you are left out with cos A minus 1. Cos A minus 1 divided by 1 because we have taken sin A as common. So this can be written as, change the sign of this and multiply both numerator and denominator. We are multiplying both numerator and denominator with cos A plus 1. Cos A plus 1 divided by cos A plus 1. We are keeping this as it is till the end. Then plus 1 by sin A. Cos A minus 1 into cos A plus 1 is cos square A minus 1. This is in the form of A minus B into A plus B. Cos square A minus 1 divided by cos A plus 1. We know that cos square A minus 1 is sines. See here it is little tricky here. Sin square A plus cos square A is equal to 1. We want cos square A minus 1. So this goes that side. We'll go back once again here from here we'll start. We're keeping the sign as it is. So sign is common here. We are taking out sin A 1 divided by sin A. We are left out with cos A minus 1. Cos A minus 1 divided by 1. Multiply both numerator and denominator by changing the sign of this. Cos A plus 1, cos A plus 1. We know that this is in the form of A minus B into A plus B. This will become a cos square A minus 1 square. So keep this as it is till the end. So this will become 1 by sin A. So here it is little tricky here, cos square A minus 1. We know that sin square A plus cos square A is equal to 1. We want cos square A minus 1. So we want cos square A, you bring this side, left hand side, that will become minus 1. This goes that side. When sin square A goes that side, this will become minus sin square A. Cos square A minus 1 will become minus sin square A. This is important because we are throwing this out and bringing this here. So this will become 1 divided by sin A into, this is cos square A minus 1 is minus sin square A. This one sign will get cancelled with this one sign of this. So we are left out with, this is minus 1 in the numerator. So we are keeping minus 1 because we want cosecant A in the RHS. You bring this down. So this will become cos A plus 1 divided by sin A, that is equal to cos A divided by sin A, 1 divided by sin A. This we are keeping as it is from the beginning, 1 by sin A, because it is already there in the RHS, plus this is minus 1, and sin A left out, we brought it down, cos A divided by sin A plus 1 divided by sin A. We know that cos A by sin A is cosecant A. So you multiply with this, and 1 by sin A is cosecant A, cos A by sin A is cot A, plus 1 by sin A is cosecant A. So we are left with 1 by sin A, this minus 1 with this will become minus 1 divided by cosecant A. 1 by sin A is cosecant A. Cos A divided by sin A is equal to cot A, that is equal to RHS. Here in this whole problem, so we need to be careful only in this part where cos square A minus 1, we need to write exactly that minus sin square A. Once you got it, minus comes here. Once you got sin A, you bring it down to the denominator. So this once it comes down, it will going to be cos A plus 1 divided by sin A. Cos A by sin A is cot A, and 1 by sin A is this. In the whole problem, this place you need to be careful, then bringing this down is important. Prove that sin minus 2 sin cube A divided by 2 cos cube A minus cos A is equal to tan A. As soon as you see this, don't get confused. We just see anything can be done with this. There is a sin A here, sin A here. There is cos A here and cos A here. We want tan A. We know that tan A is equal to sin A divided by cos A. So take out the common from here and cos from here. Sin A we are taking out. We are left with 1 minus 2 sin square A. Cos A from here, cos A we have taken out. The left with 2 cos square A minus 1. We know that sin A by cos A is tan A. So we got the answer for this. What we need to do is make this equal to 1. So keep this sin A by cos A is equal to tan A in the rest of the problem as it is. Try to see that whether you convert this whole thing into 1 so that we get the RHS. So don't disturb this because we already got the answer. Only thing we need to prove these two is equal to 1. We know that 1 minus 2 sin square. Convert this. See, what is the option left out is we don't have any option here. 2. Convert this into cos form. 1 minus cos square A divided by 2 cos square A minus 1 we are keeping as it is. So in the numerator it has become 1 minus 2 into 1 minus cos square A. That will you bring in this inside. 1 minus 2 into 1 is 2, minus into minus that is plus 2 cos square A. Here 1 minus 2, 1 minus 2 is minus 1. This will become 2 cos square A minus 1. From this step to this step, 2 cos square A minus 2 plus 1 become minus 1. 2 cos square A minus 1. In the denominator we have 2 cos square A minus 1. This and this will cancel. This will equal to 1. That is what we required. Tan A is equal to, that is equal to RHS. So as soon as you see this, keep this as it is. Don't keep doing anything with this part because we already got the part of answer. Only thing is we need to convert this is equal to 1. See how we can convert this into 1. You can always try with the numerator or the denominator. We are trying with the numerator. So we converted. So to make it these two equal to 1, we need to make numerator and denominator equal to 1. So for that we need to convert this into cos or this into sin. We are converting this into cos. So you don't change anything with the denominator. Change only the numerator part into cos or denominator to sin. We are changing the sin part to cos part. Sin square is equal to 1 minus cos square A. After rest is simple calculations, we got is equal to tan A, that is equal to RHS. Prove that sin into tan A divided by 1 minus cos A is equal to 1 plus secant A. So we have a secant A on the right hand side. Whatever we do the problem here when we are solving this, we should see that we keep all the things in the form of cos because 1 by cos A is secant A. So now we cannot convert sin to cos. So because sin square A plus cos square is equal to 1, then only we can do anything with the sin. So let us change this tan theta, sin theta by cos theta. So we are changing only this part. We are keeping as these two. We don't change anything with the cos. We need to change with the sin. Sin cannot be changed unless it will become a square here. Then because of that we are only changing the tan theta. We know that tan theta is equal to sin theta by tan theta. So once you change this sin theta into sin theta, sin square theta, we have an option here to change this sin to cos. So sin square theta, so this comes here cos theta into 1 minus cos theta, sin square theta. We know that sin square theta plus cos square theta is equal to 1. Therefore, sin square theta is equal to 1 minus cos square theta. That is what we are doing. Don't do anything here. Just see whether you can change this to sin square. That can be done by changing the tan theta is equal to what, sin theta by tan theta. Once we got the sin square theta, don't think too much about this. Then change this into cos, because we want cos on right hand side, so that we can convert into secant. Sin square theta can be written as 1 minus cos square theta. So we have here, this can be written, see, as soon as you see that, don't get in this one here. This is in the form of a square minus b square. This can be written as a plus b into a minus b, because we have one more here. This numerator can be written as a plus b into a minus b, that is 1 plus cos theta into 1 minus cos theta. This one part here and one part will get cancelled. So we are left out with 1 plus cos theta by cos theta. 1 plus cos theta divided by cos theta. This cos theta belongs to both 1 and cos, then 1 divided by cos theta plus cos theta by cos theta. We know that 1 by cos theta is secant theta, plus cos theta by cos theta is 1, which is equal to, this is RHS. So the 1 plus secant theta, that is equal to RHS here. Hence we have proved. Prove that 1 plus cot A minus cosecant A into 1 plus tan A plus secant A is equal to 2. Nothing is there other than the digit 2 here on the right hand side. As soon as you see, don't get panic. Just change the cot and cosec, whatever it is there, into sin and cos. That afterwards it will become easy for us to solve further. So let us change everything into sin and cos. The one we are keeping as it is. Cot A is cos A divided by sin A, minus cosecant A is 1 by sin A into 1 plus sin A divided by cos A plus 1 divided by cos A. As soon as you see this, there are sin A here, cos A. Simply take the LCM here or a common. Once you take 1 by sin A as common, here is sin A, not 1 into sin A. Then sin A we have taken common, cos A minus sin A we have taken common, minus 1. Here in this also take out that cos A as common, 1 divided by cos A we have taken as common. The 1 into cos A plus sin cos A we have taken common, left out with sin A plus 1. So this we are keeping together, the sin A and cos A, 1 divided by sin A and cos A. So when you see these two things, see these two things, this one sin A plus cos A plus sin A. See the sign here changing, minus 1 plus 1. It is in the form of whole thing, this as A, this part is A, and this part as, take it as A, 1 as B. A minus B into A plus B form. So we are taking these two together, we are keeping these two together, 1 divided by sin A cos A. Take this whole thing as A and whole thing as A minus B plus B. A minus B into A plus B, A square minus B square. Sin A plus cos A whole square minus 1 square. 1 divided by sin A cos A we are keeping as it is. So expand this. A plus B whole square, A square plus B square plus 2AB. Sin square A plus cos square A plus 2 times sin A cos A minus 1. We know that sin square A plus cos square A is equal to 1. This is 1. This one and this one cancelled. This is plus 1, this is minus 1, get cancelled. We are left out with 2 sin A in this whole bracket, because when we expand this, sin square A plus cos square A plus 2 sin A cos A minus 1, it has become, we know that sin square A plus cos square A is 1. This plus 1 and this minus 1 will get cancelled. We are left out with 2 sin A cos A. 1 divided by sin A cos A into 2 sin A cos A. Sin A cos A get cancelled with sin A cos A. We are left out with 2, that is equal to RHS. Prove that square root of secant square A plus cosecant square A is equal to tan A plus cot A. You see, just see the right hand side. This is tan A cot A. We want a sin A by, on the right hand side we want tan A plus cot A, which is sin A divided by cot A plus cos A divided by sin A. Change this left hand side into the cos and sin form. Secant square is equal to 1 by cos square A. This is 1 by sin square A. Then the square, take the LCM of these two, that is sin square A cos square A. This will become sin square A plus cos square A. So square root of, we know that sin square A plus cos square A is 1. divided by sin square A into cos square A. Remove this square root, that is square root of 1 is 1, square root of these two is sin A and cos A. So once again we are replacing this 1. See, earlier we have replaced sin square A plus cos square 1. Once we come out of this square root, we are replacing this 1 with the sin square A plus cos square A. So then sin square A divided by sin A cos A plus cos square A divided by sin A cos A. Sin, one sign here will get cancelled with one sign, we are left out with sin A cos A, and we have one cos A with get cancelled with cos A, we have left out with cos A divided by sin A. Sin A cos A, sin A cos A is tan A, sin A divided by cos A is tan A, plus cos A divided by sin A is cot A, which is equal to RHS. So we have proved. In this problem, the thing is, we have taken here the 1 back here. Say in this place 1 we have taken, this is very important place where you have to change 1 is equal to sin square A plus cos square A. Rest is simple calculations.